The spell Cloudkill in D&D has always annoyed me because it's not quite complicated enough. So I'm gonna fix that. The spell's pretty simple, you just make a sphere of poisonous fog. Everyone inside the fog has a bad time, everyone outside the fog has less of a bad time, but there's probably still a bad guy to fight. And what's always annoyed me is it stays like that for 10 minutes, and then it just vanishes. So there's a really hard boundary between where the fog cloud is and where it isn't, and that annoys me. Because clouds don't do that, gases don't do that. Instead, they undergo a physical process called diffusion. Diffusion is basically just if I have a lot of something and there's a big difference between them, then it'll spread out until it's a bit more equal. So you can think of it like temperature. Temperature and gas, they both follow similar equations. If I have something really hot here in the middle and something quite cold on these outside bits, that heat is going to dissipate throughout this whole space. Now, the interesting bit is how quickly this happens is dependent on how big this difference is. So to model this, we need a kind of equation called a partial differential equation. Now, I'm not going to cover PDEs in full detail, but actually on a fundamental level, you can probably get what they are. Usually when you're looking at equations, we have something like this, where there is some value x that you're trying to solve for. So this statement is true for some value x. What a partial differential equation is that makes that little different is instead of solving for a number, we're solving for a function, and this is super hard. It's actually like one of the big challenges of physics and maths at the moment. At the very least, it challenges me. So this one, for example, is called the wave equation. The actual wave bit is this thing y, and this symbol, this curly d, is a partial differential. Basically, it just says we want to look at the difference in y with respect to a small difference in time or in space. The whole curly d thing is just saying don't worry about it, only differentiate with respect to time. And because of the two, we do that twice. So we're looking at the rate of change of y with respect to t. So one famous solution of this is just a sine wave. Nice and simple, you know, it kind of goes like that. For our Cloudkill spreading out, we're going to be using this equation here. So this phi, this is the function we're solving for. It's got space and time in it. And this is just a coefficient telling us how quickly it moves out. So the change in the density with respect to time is equal to some coefficient times the rate of change of this in space. Don't worry if it's confusing, I've got an animation. Basically, it looks like this. We can see in the middle there, that's our Cloudkill. Focus on the thing, not the pen. If we start with the uniform circle like Cloudkill does, then eventually it's just going to start spreading out into the room around it, which means the dangerous area is going to shrink. And so I've derived this. As the number of rounds goes on to 100, which is the limit, the spell should shrink in its area of effect. So if you're ever in combat for longer than 100 rounds, my apologies, oh my god. But just let your DM know, the cloud should be really small by then. I'm going to look at some more overcomplications. Have a lovely day. Okay, bye.